So we're going to do the pH scale notes. Okay. So this, hold on, let me get myself some room here so we can see what we're doing. So this top part, you can put it in there if you want. That's just sort of a reminder of what we've been like of the equation. Yeah. What's that? Yep, I got it. You're good. So this is just kind of a reminder of what we've been using to calculate, the concentrations or whatever. Um, so the pH scale, um, we express. So remember when it's in brackets like this, it's talking about the concentration. We express the concentration of hydrogen or hydronium in terms of pH. So there's actually an equation. I guess I don't know, some kind of interesting. I didn't know that until I started teaching this. That it's actually pH is a mathematical calculation. I mean, I knew it was a number, but there's actually a mathematical calculation that goes along with it, which is it's a logarithm. So the pH equals negative log of the concentration of the hydrogen, or remember, right? We said you could swap hydronium in for hydrogen. So yeah. Yes. Yeah. Yep. Log. Yes. The log is base 10. So which yeah, because it says down here, a change in your concentration of hydrogen by a factor of 10 causes the pH to change by 1 unit, right? So most pH values fall between 0 and 14, right? Now, think about this. What's your exponent? Negative 14, and that's a multiple of 10, right? Like it's a decimal movement for the exponent. So if you think about that, like your um, your scale is going to be directly related to the um, the concentration that you have of each, and it's going to be, and you're going to like you'll be able to see it in the like with the exponent. So um, so you guys know this, right? As the pH decreases, acidity increases. So as the number goes down, as the pH number gets lower, that's more acidic. So um, if you're looking at a pH scale, my marker, um, if you're looking at a pH scale, a 1 to 14, with 7 being neutral, the further this way you go, the more acidic you are, and uh, the more above 7 you go, the more basic it becomes, stronger base. You guys have done this stuff before, right? I don't want to. Yes. Okay. I want to make sure because I don't want to just blow through it if people don't know it. So blah 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 blah. Okay, let's do which one? Okay. Well, actually, let me talk about this and then. So this is something that I totally didn't know until I started teaching this. Um, there's a pH scale. There's actually technically a pOH scale. Um, it's the reverse of the pH scale, but like pH scale is based on the concentration of hydrogen. If you base something on the concentration of the hydroxide, there actually is a pOH scale. It's the reverse. It's the flip of it. So you can see like here. Maybe I should highlight that because. So if it's the POH scale, then it's the same equation. You're just swapping in OH wherever the hydrogen is. Now, luckily, there is something that we can do that can make our lives a little easier with this. And there's another equation, which is because they're directly related, the concentrations and the scale, you can take the pH plus the POH and it will equal 14. It will always equal 14 for like one substance. The pH plus the POH for a substance will always equal 14. The same way the concentration times itself, now this is times, not plus, but this is times, will give you 1 times 10 to the negative 14th. If you add these, they will give you 14. So we can convert back and forth between pH and POH and stuff, or we can kind of just use this. So there's actually it's called an acid-base tool. If I haven't ever typed this up, I could try to type it up. But essentially, these are all like how you can find parts or go between them. Like going between POH and OH, you use these. Going between pH and OH, you can use this. Going between pH and concentration of hydrogen, you can use these. And going between concentration of hydrogen and concentration of hydroxide, you can use that. It's just sort of like putting all of the ideas from the past couple of days all together. So maybe I'll try to create a nicer looking one and give it and make a copy of it for you guys. All right. So okay. So I have some other equations here to help make your guys' lives easier. Because based on what they give you, they're sort of expecting you to know how to do the math. So what I've done here is I've based it all off of this. Okay? If x equals the log base, we're talking about base 10. If x equals the log base 10 of a, then 10 raised to the x equals a. And a equals the antilog of x. So this goes from left to right across like this. You're looking at it this way, from left to right. So then what I did down here in the second row is I did an example with putting the pH and the H in. So I put the pH in for x, technically negative pH. I put the negative pH in for x and the H plus for A. Okay. And by the way, in case you're wondering why it's negative pH for x, it's because up here we had pH equals negative log of this, so I just moved the negative to the other side. Okay, that's where the negative comes from. So I could keep my log positive here. So if it's the negative of the pH equals the log of the concentration of the hydrogen, you can also do it like this if you're solving for one of these. Okay, so like in other words, say they give you pH and they want you to find the concentration of hydrogen. Sometimes people don't know how to undo this. This is how you would do it. You take 10 raised to the negative pH, and that will give you the concentration of hydrogen. Okay, and then this is just, this is literally just another way to write this. I think I did that because I think the book somewhere talks about anti-logs, and I'm like, okay, what, so I think I put that in there to do that. And then, oh, I had under here, I just had that. I didn't even see it down here. Okay. You can swap POH with pH in any of these and swap OH negative with H plus. So in other words, these exact same setups you can use with POH in the spot where the pH is, and then the concentration would be OH negative. Does that make sense? Yeah.
Is this going to seem a little bit more straightforward when we start?
Is it going to be what?
More straightforward.
Yeah, like basically, this seems confusing, but what I'm doing is I'm basically giving you all the different ways you can solve for something, because I didn't know how people would be with logs and stuff.
Yeah.
And like, so in other words, if they gave you a pH, I didn't know if people were gonna know how to undo this to solve for the concentration. So that's why I gave like the other one.
It's gonna be a stupid question.
Yeah.
But if you, like you're saying that you can swap with OH, if
Uh-huh.
you did that, it would still, it's just gonna give you a number on the pH scale, right?
POH scale. So in other words, if you have an OH negative and you plug that in, then you're finding the POH.
Yeah, so but it's still gonna be on the pH scale, right? Like,
It would be the reverse of it. So like, okay, so for example, it would be this. So like if you got a POH of 6, your pH would be 8. Think of it like, yeah.
Wait, so if you're solving for the POH, then the 1 to 7 is basic and the 7 to 14 is acidic, right? It's
If you're solving for the, yeah, on the POH scale.
Yeah.
Yeah.
Okay.
So like, hold on, let me find okay. So on this thing, right? Think of, I'm gonna mark mine up here for a second. You don't need to do this, but I'm just kind of to show you guys the idea. So think of, yeah.
Can you draw the POH scale on the board that's underneath the pH scale with 0 on the right, 14 on the left?
Yeah, that's what I was gonna show here. Is like, so if you imagine the acid column as being the pH scale, you would have the strongest acid would be a 1, and the weakest acid or the strongest base, however you want to look at it, would be 14. And if you had the POH scale, it would be the flip of that. So, yeah.
Is there a reason why they're starting with 1 when on the notes it says pH values fall between 0 and 14?
Oh, I don't know. I've never seen, just because I've never really seen pH values of 0. So I usually think of it as 1, but it can be 0. It's fine. Yeah. 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 So,
I guess I don't understand the purpose of the OH scale.
what's that?
I don't understand the purpose of the OH scale.
The purpose?
Yeah. I don't understand why that's like.
So
Like,
it's
gonna have to use it? It just seems odd. Like it shouldn't be there because it should just be black and white.
Okay, so the answer is yes and no. Like generically, could you do you need it? Like, not really, because you can convert everything that would be on the POH. You can convert it to in terms of pH.
I didn't even know that there was a POH.
I know. I didn't either. That's what you
I guess so.
the idea, well, hold on, okay. So I think that the reason that they do this is they want you to think of it in sort of in terms of like, these are like concentrations and equilibriums. So like whatever you have on the one, like the pH scale, the pH scale is a representation of the pH scale is a representation of how much the concentration of hydrogen, right? It's like a representation of the concentration of hydrogen.
Okay.
The more hydrogen you have, the stronger the acid, the lower you are on the scale, right? The POH is a representation of the hydroxide,
So,
which
so like the left side is basic and the right side is acidic.
right, yeah.
Okay, that makes a little bit more sense.
So do you really like? No, you don't really need it. But I think the sort of like purpose of all of it is kind of show you that in everything, if we go back to this idea of it being neutral, if we go back to the to this of like the neutralization of water and you can't really see that and the fact that like if these are equal, then it's neutral. So if you're talking about concentrations, if you have more hydroxide, it's going to be basic. If you have more hydrogen or hydronium, it's going to be acidic. And they just want you to think of it in terms of a balance of the two, sort of.
Are we gonna have to use the OH scale?
Actually, use the scale, no. I'm going to want you to know how to convert like what we're doing, but you're not actually have to use it. Yeah.
Do you want a concrete example of where the POH scale could be useful?
Sure.
Sample exercise 16.6, part C. It's a little bit easier to convert from the POH scale to the pH scale than it is converting between polarities.
Right.
Well, I've already done that.
It's actually, I read the
Why
book.
would we convert between the
The
letters?
whole thing.
So what he's saying is if you have the POH
Or if you have the molarity of
or the molarity of the hydroxide, it's easier sometimes to convert like this. Like, so in other words, if you have the POH, it's easier to find the pH by just using this equation, by doing 14 minus the POH, and now all of a sudden you have the pH. Versus having to turn the POH into the concentration of hydroxide, turn the concentration of hydroxide into the concentration of hydrogen, turn the concentration of hydrogen into the pH.
or in this example, just starting with the concentration.
Right. Yeah. So, okay. Yeah. Let's go to those. Let's look at some of the examples that will probably help. So, let's start with calculating really quick. Calculating pH from hydrogen. So, calculate the pH values from the following scales. So, hold on, let me get my stuff all organized here.
Taylor, what time did we get out of here?
55. Okay. Yeah, 55. Okay. So all you're doing, calculating the pH values, is you're just using this, depending on what you have. So pH equals negative log of the hydrogen. So 1.0 times 10 to the negative 12th molar. Right? And then you just literally type that in your calculator. So oops. So pH is 12. Now, here's the easy part of it. If this is 1.0, then, right, whatever your exponent is, that's your pH.
Regardless if it's negative or positive.
You're not gonna get a
You're-
positive.
Yeah, you won't have a positive, because positive is gonna be like a really big, so they're all negative. So. Okay, so if it's 1.0, then your exponent will be, your pH will be whatever the exponent is as a positive, not instead of a negative. Okay. Now let's look and see what it does in B here. Same type of idea. pH equals negative log of 3.8 times 10 to the negative fourth mole. Okay. pH, you're gonna round to, they usually say the number of decimal places that, like whatever the number of decimal places that the significant figures are. So like if there's 2, then you go to 2 decimals. I'm kind of lenient on it. Again, like you should go to at least 1 decimal if it has a decimal. This is 3.42 or 3.4. Okay. Now, this one, again, there's a couple of ways that you could do this. Okay. One way would be to use this to find the hydrogen concentration and then turn the hydrogen concentration into pH. Or the way that I'm going to do it is I'm going to find the pOH, and I think this is what Zach is referring to. And I'm going to find the pOH, so it's negative log of 1.9 times 10 to the negative 6. And we get a pOH of 5.72. And then we have this equation, the pH plus the pOH equals 14. And we just plug in the pOH. And we get a pH of, 8.28 or 8. Okay. Makes sense? Okay. All right. Let's look at this one. You got a couple on here. Again, these won't take long to work out. You just have to use the right thing. So here we've got a pH of 3.76. We want the H plus, right? So I'm going to use this, the 10 raised to the negative pH to the power of negative pH, to the exponent equals the concentration of hydrogen. So 10 to the negative 3.76. So gives me 1.7 times 10 to the negative fourth molar is the hydrogen concentration. Everybody okay so far? And then this is the same thing, just with a different number. So you would set it up exactly the same way.